Power functions are the next type of common functions you will encounter in calculus. A function f of x equals x to the power of a, where a is a constant, is called a power function. Consider the following cases. A equals n, a positive integer. These functions are defined for all real values of x. Notice that as the power n gets larger, the curves tend to flatten toward the x-axis on the interval, -1, 1, and to rise more steeply for absolute value of x greater than 1. Each curve passes through the point 1, 1, and through the origin. The even-powered functions are decreasing on the interval -infinity to 0 and increasing on 0 to infinity, whereas the odd-powered functions are increasing over the entire real line. Consider the case when a equals -1 or a equals -2. The graphs of functions f of x equals x to the power of -1 and f of x equals x to the power of -2 can also be written as f of x equals 1 over x and 1 over x squared respectively. Both functions are defined when for all x does not equal 0. The graph of y equals 1 over x is the hyperbola xy equals 1, which approaches the coordinate axis far from the origin. The graph of y equals 1 over x squared also approaches the coordinate axis. Finally, consider when a equals 1/2, 1/3, 3/2, and 2/3. The functions f of x equals x to the power of 1/2 equals the square root of x, and f of x equals x to the power of 1/3 equals the cubed root of x are the square root and cube root functions, respectively. The domain of the square root function is 0 to infinity, but the cube root function is defined for all real x. Recall that x to the power of 3/2 equals x to the power of 1/2 cubed, and x to the power of 2/3 equals x to the power of 1/3 squared.